you change the dimensions of your box by going into VI instead of doing the tint to VASP?
Then you need to re-optimize, because if you expand size of the box, it will automatically expand proportionally all point distances.
Oh, that's right. Yep.
Which is not a big deal. I'm okay with this.
Well, I realize because the way my box is oriented, it's just going to make copies instead of elongate it. So
You could always just steal Dimitri's.
I could,
Which you are welcome to do.
but it worked. So
At no time you will do, each of you will do individual projects, so there will be less chance to borrow from me or from each other, even if you had such
yeah.
thought. Good. Sometimes with these grep commands, you get all zeros.
I was just doing it step by step.
Did it work? Well,
Just checking that.
worked.
So this
So,
one for screening.
The way mine's drawn.
How many step would you in first or in the
Mine's drawn. So
There are two sections.
I don't think this worked because he said that this is your energy and this is not energy. It's zero. So I don't think mine worked.
What about the sixth column? Sixth column is
so
not.
I'm propagating along this axis.
My sixth column is waves.
I have to propagate it along
No,
the
no, there are two
y-axis
sections.
if I want to get the polymer.
Change your K points.
I
Mine's
You
all
get your
zero.
rotate it.
I have to do it in the XYZ
Last
file
column?
and rotate
This
it.
is on zero.
And I'll make a separate
When
file.
I
And that's weird. Yeah.
How do you
Run them both.
when I do that, I get
Manually, like
I don't know.
and then right,
I got what he got.
zero.
right click?
yeah.
That's
For
because
some
of
reason,
the-
energy
he
one.
doesn't.
You may,
want to
I got mine.
case is not making difference.
Mine's still going.
Because no, you see these two
So
sections.
maybe as this is going, I can do another one.
These have more space. So if I put the more space, it will grab this. We want this number, not this.
I thought Dimitri said that this is our energies here. Because if we do 1, 2, 3, 4, 5,
6 is what?
6 would be this second decimal. The third decimal. But I don't know if I did it wrong or.
Okay.
Yes. So
You see?
that number has to be the number.
Yep.
Points. Okay.
So we do positions. And it may go through the list 2 times. Just 4 points. Good. But the rest should be easier. Four of those.
So if we expand from the X, this
Right.
Okay.
Number has to be the number of
Just
K
copy
points.
from the out of the video.
That's the only difference.
And do not run, just go immediately to the processing flags.
For the K point line, the star. Money sign. Yeah, so that's the number for K
So
point.
instead of only having 1 unit cell or 4, we're gonna have 16.
Okay, so 16
Or
change it.
how many does it? So you did. So your K point file has 8. Then how many does?
Around
Like
the-
an
My K
alpha.
point has 10, but my
So only
out
K
part
point will change.
has 8.
And then your in-car file.
And
Just
the
like
8 didn't
you
work
have.
either?
Because the money assigned prints the eighth column.
And that's W, so it says 1.
So when you
right now.
say 6,
You change it to 0.
Oh.
that says
okay.
print the sixth
Yeah,
column.
So there's just not gonna be
So if I get rid of the awk command,
Oh.
No,
this is
no,
what
no,
I
no,
have.
no,
Okay.
on that.
I fasted mistakenly in your.
when I add the awk, it says
Yeah, but
Yeah.
print
you do
the
the
sixth
first
column. That's
Yeah,
what money
now
assigned.
I-
And since several
Like
people
1,
were trying to
2,
do
3,
something
4,
better, it can be already
5,
a
6,
little.
8, 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. All zeros.
So maybe you just put in 4.
Excellent.
Those look like your K points. So maybe it's the 4th.
I'm running this commands line by
And
line.
if
Okay,
you do
okay.
4, then it's gonna get us
Yeah, they start two different column, but
Weird.
they have no space. That's why it look like one
Yeah.
one column.
So it's gonna.
Oh.
So that's why I think my calculation went wrong, because when he went through his output, said that these were the energies, and I have all zeros. So I'm assuming that there are 3 columns here that all converge to 1 because of the zeros. Does that make sense? Because then this would be my 6th column, and this would be my 6th column, and these, if these weren't all zeros, then it would have some energy.
So I change the 16 because.
Yes. Everything is very good.
Check your. Let's go to the out card and see what the actual K points are, or K values are.
Oh boy.
Just check.
Yeah, I have the same thing that happened to you with the first column printing out the extra zeros. But the first digits though, those are, I know those are my K point values, because I did this earlier. I went
Also,
through
the
my-
first lines of K point values?
Yeah, so those first digits are, and then it looks like you just printed them twice.
But it comes out from
I don't know. Oh, see, Dimitri, this is his are, if we would assume that these are supposed to be 3 different columns, then this would be the 6th column for him. So that's why I think something went wrong with my calculation or something. Oh, this is in the Z direction, so ours is in the X direction, so that would be the
X, Y,
first.
Z.
So it would be the first column.
So that's what it's for.
But it's really weird, because if you did 4 or 5, if you do anything but 4, you wouldn't get this like energies. So then how do you determine if this, like if you had an energy here, like a, yeah, it's weird, I don't like that.
I think there's,
Because if you made a quantum wow, like a sheet, then you would have K points in both X and Y or 2 directions, so then you would have like overlap. It's weird.
Quick question. If I'm copying a file from Dimitri's, how do you copy it? So I've only copied stuff like back one directory.
You put a period. So you say CP, and you write the path,
The entire path? Like, so I
to
can't
his directory.
So I start in my own directory.
Yeah, so like if I wanted to copy this, so this is his file, right? So if I wanted to copy that, I would say CP, the directory. I could also go backwards, so I could do 1 dot dot dash, 2 dot dot dash, 3 dot dot dash, 4 dot dot dash, Dimitri, and then go into his file.
Four dot dots.
So dot dot dash
Yeah.
means go up a directory.
Okay.
A
So you tell me-
period means this directory. So like I'd go up 1, 2, 3, 4. So I would have 4 dot dot dash. Like 1, 2, 3, 4.
I gotcha.
Or I can say, okay, I'm gonna start from root directory and go forward. So you can do it either way.
So, okay, that makes more sense. I was wondering how to go back, so the number of dot dot dashes is how far you back.
Yeah.
Yeah,
If I wanna go forward, I just use it.
no.
Yeah, it
If
did.
you wanna go forward, you just type the path.
We can just paste it.
Thank you.
Okay, so if I'm in my own directory,
Now Control C.
I type his, like, CHEM476.
Yeah, so like if I copied this, I would do so
And this is gonna go to your,
This line.
that directory right
so just like SCP, you say where the file is, where the file is going.
Yep.
So this is where the file is, this is where the file is going. If I wanted to put in a subdirectory,
Oh, yeah, extract.
then I do the subdirectory and the name. So then I can do more, new, test this out, and now I have this
So
file. Does that make sense?
Let me do that one more time for me. I'm slow.
Okay, so let's say I wanna go back 2 directories. And now I do make copy. Copy, right? So I made a new directory. And I say copy. So CHEM476 2006 Dimitri C2H10 Z out. Right? So the command where the file is. Now where do I want to go? So I made a new directory copy. So I put it in there, and now if I do ls copy, I have the file.
Okay.
So, but if let's say I didn't want to put it in a copy, I wanted to put it in this directory, then I can go back. Right?
Okay.
But you cannot say this. You cannot say copy the file.
Yeah, it's because you don't have it where it's going.
Yeah, you don't have a list.
Is this Oscar 1? How do you get this file? Oscar 1?
That's just how he named it. I'm assuming you just copied it.
But it's running the same history.
I don't.
But yeah, I'm getting, from the Oscar, I'm getting the energy. Yeah, this one.
I don't know.
How do you get the kick?
So, Aaron, do you know if the energy of the K point the momentum can be greater than 1?
No.
No? Okay. That helps. Okay.
Cause I'm just trying, cause if it's based off percent, if it's like percent,
Then it would be
then
greater
one,
than the unit cell.
yeah, and there's no need to go outside the unit cell, so I guess
And
that's
if
probably why.
you were going outside the unit cell, your
Your
velocities
system
would
has
be
more than 9
quite
products,
large.
so you need to.
And then VAST, I don't think can handle it because most of the codes
The
are
same
not
thing as
related to
everyone, but everyone does C4H, C2H.
which you would have to have if you're
I
going
have 16 already.
fractions of the speed of
Good
light.
for training. If
Mhm,
you do
well,
research, then
For
some
accurate
additional
predictions
corrections.
anyway,
No,
you can probably still do it, it'll just,
Not be so well.
On the way back. Check the files
I have
and
done the-
not zero.
Last
so does anyone
Look
figure
inside
out the
more K9.
second line, for how to pull
Yeah,
out
so I guess can I?
Yeah, I
just
have
think
put
they're-
out.
good energies of the orbitals.
Good.
Yes.
Your signal.
I just got a
And
bunch
then?
of junk.
No, because it took me a while to figure out what we wanted from this. So we just want
You
this.
just want this figure.
I obviously. But where we pull it out because since they're all together.
So do it this.
Wait, we want the energies? I'll let you do yours.
Yeah. Then. Each and every. Yeah, each and every. Oh.
So we need first code. 1, 2, 3,
Oh, so
4.
we want this, not this energy.
Do you need any information from
Oh,
the
okay.
outer file? So it will extract some information. This command
Okay.
will extract. Oh, okay. It will automatically extract. So first I need to write.
It's not energies, it's values of K level.
Okay, so these are the energies.
This parsing command is not ideal. You can design it such that it will extract only those.
Okay, but this is what we want.
Yes.
Okay.
Okay. Just in case something gets corrupt.
You automatically can choose the writing over, right? Yeah. Okay. Then you can go to online. So
You know you can just do an R at the end and then the last one would be.
let's go.
Okay. Let's do. Run the C2HD.
I thought we were doing. Oh, sorry.
Let's do the same exercise for everyone so that we don't spend too much
All
time.
the other lines.
And improve them.
Okay.
You see for H4, number of orbitals doubles. Therefore, if you count for 10 orbitals, you get only the lower half of the.
Okay.
But
So,
right now, we.
I'll look at the script and I'll copy it and
And
bring it.
if you have time, you can make it generic so that it will just run in cycles.
So take me out from this.
Merge together.
So where's the L1? L one come from? Oh, so
I changed it to myself.
It shows that most of
Just this one is I anticipated.
thank you.
So I have to one bit along the y-axis. My box is way too big and I can't shrink it.
No.
So if I do this minus it, to adjust it by that much.
This one? Or are we still working?
Yeah, or attempt to do it.
That's just the script.
But what number? What in here?
Oh, you just leave a space.
This space? But it doesn't work.
You can just type in
Somewhere else.
tilde
So you-
slash bin
you-
slash.
you-
right.
You have a stock file
And then copy this one.
with the
That's right.
value.
No, that's
I'm an
in the
idiot.
script.
And
So
you're
you just
going plus or
run.
minus
Yeah,
from that stock number.
yeah. So what I should be doing is to figure out what the stop is. Oh,
I just don't put them
Like
more.
if you, yeah,
You
if
add
you
one
just
to it.
type in
right, so I should
that.
to that, minus to that, B6.
after making
Oh,
the
okay.
KK,
Just type in that one.
then
Okay.
that runs it.
Make what?
Holy
what
shit.
KK?
The
Oh, okay.
Jeez.
It's almost like, you know, I listen.
You take.
I'm not a very smart man. Oh boy.
You are doing that in a separate one, right?
Yes.
So
yes.
it's not gonna
Yep.
overwrite?
Yep. Okay. I have solved my own problems. Okay. Let's go ahead and remove this.
Shift insert. Like this. Just paste this.
Oh,
You have the home directory.
Okay.
So it looks like so.
Don't worry at all.
So unless so if you don't start at the root directory, you have to have this. So if you do copy, if you do just like this, it will read in this directory, right? So you have to tell it where to start, and by default, it's within the directory.
Okay.
And this does what? It tells it to go to the very beginning.
So the tilde, that means go to my home directory.
PDF file and see how it looks like. Oh, maybe I
And
think
since
it's done.
in this cluster, the home directory is also the working directory,
Good.
Yes.
it's
I
fine.
figured out my problem.
I still have
Right. If you work with CCAP, your home directory, you are very limited to space,
From the class.
like gigabytes of space. Where sometimes a calculation might need tens or hundreds of gigabytes to be able to run. So here they have a thing called Scratch instead of home, so that is why it's very important to know where you're copying stuff. And if you do backslash, that means start at the left directory. So if you can you do PWD?
Just now?
So what does it say? Home, clean,
So-
clean lab.
If I started here from the very beginning, start doing the tilde, that would work.
Yes.
So this tilde slash starts me, gives me all this information.
Yeah.
So can I do a tilde slash and start the same? Or does that?
No.
Just I can.
Because how the cluster's set up is we're all on one account. And there's only one home directory.
And that's the CHEM476.
No, that's clean lab.
Oh, I see. That's the home directory, so I do tilde. Start from there.
And then you go to chem whatever.
I
Right.
see. Yep.
So if you don't have a forward slash in front of anything, it means start at my directory and go.
Okay.
If you have the tilde slash, that means start at
What are
home,
key points?
clean lab.
Velocity, average
And then
velocity with which
whatever.
all electrons
And
move
if you
at
have
once.
Okay.
just the
That's actually-
forward slash,
Yeah.
that
If
means
there
start
are
at root,
others,
and then I'm gonna tell you exactly where to
It
go.
is periodic,
But
then it is
The,
same
the
pattern.
lowest,
Is again,
the, like,
so that'd
if
be
you think
home.
about,
There's a conjugated
no,
polymer.
no, home is your home directory.
Infinite is
Root
continuous.
has home
And
in
the
it.
replicas going with different velocities.
So just type CD.
Um,
Now do PWD. What do you see?
download this file and put it in
Oh,
PDF.
sorry,
Just
CD goes
bring this one
home.
to your
So if
Okay,
we
so
go
that's
here,
You
the
don't put
copy.
it
now if we do, it tells us
so we
forward
go
slash, so
to
that means you're in the root.
where we are, chemistry,
Okay.
this one.
So
So the
Then
next
just
one, if I
find
want to
this
move
directory,
forward, would be.
double click.
So like if you think about like a family tree, right? You have your make,
All
and
good.
then you,
It's not pulling
but is,
out the
There's
There's
energy.
no name for that, it's just the backward slash type of thing.
that's
That's the root.
yeah.
Okay.
So if you watch
That's because you're doing
person
different-
of interest, do you want?
You do.
There's a person on there called Vert, and she's a hacker. And another thing,
No, I didn't save this K1, but I ran it.
if you are a Vert, that means
Just to see what it
you are
output
the system
before saving
admin,
it.
and you can do whatever you want on the system. Even if the people have password protected stuff, you can. It doesn't. You can just. So you don't want to make the Vert mad at all, ever, never.
Who's the person?
I don't know.
No?
No, Dimitri's not the Vert. He's a user, not an admin.
So the root's the same guy
It's a
that
big pain to be an admin.
Yeah, it is a.
You want to
You
get as much privileges of admin, but as
Yeah.
less responsibilities of admin.
right.
Okay.
But I would trust Dimitri as an admin.
No.
No.
People were suffering for the whole University of Washington when I was doing this job.
Oh. You were. Oleg was paying you as a postdoc, and you were being the admin.
He was, we are on the record. He was saving money, and he was not paying for it. He made someone else to pay.
Oh, okay. That's logical then. Because that it's a pain.
I would not like to be an admin.
No. Gosh, no.
Because if something goes wrong, you're
Oh yeah.
fix it.
Okay.
And everyone's like now. On our server, we had 3 drivers fail within like 2 months, and half of everyone's data was lost.
Maybe you should back up your data.
That is our backup.
As many
The
orbitals as you want.
admin.
But if you're happy with
What?
just
If
3
I run like you
orbitals,
said, just the tilde bin stuff, and then they say permission denied, what does that mean?
Tilde bin?
Yeah, all this.
Did you write it right?
Yeah. If permission denied, what does that mean?
That means that your user can't look at it.
Oh.
So you
as many orbitals as
you did tilde bin new log ban before
That's the
can.
last day of this classroom.
Wait. Eh? Oh. Well, no mind. I think I got it. This-
then you put it.
This thing is in. This thing is in here.
Well,
I'll have to modify it, right?
automatic, yeah, it is different, but you can just download and plot with Excel, or just do.
Okay, I really need to start working because I haven't not looked up.
First band.
Jabba, are you getting worried?
I'm enjoying this.
Make sense?
Yep.
Can I watch, or is it a secret?
No, we're just talking about the election again.
Okay. Not everything.
Well, I think I need a copy and the postcard and all that stuff I just got. Yeah.
No, just copy. One. Three. It was not correct. there is a whole field. Here's where did I? No. Need to modify. You watching and understanding what I'm doing.
Yeah.
You don't need. So, well, first, if it was for me, it was 6 column. I wasn't showing, but in this list of ASCII. Why number 4 versus number 6?
The money sign tells Arc what column to read. So if you say print money sign 1, it will print the first column. If you say money sign 2, second column. If you want to print multiple columns, you just do money sign 1, money sign 2, and if you want spaces between them, you put quotations. Does that make sense?
Not
Kind of.
So if we do this command manually, the basic
Did I ever get the
Yes,
space?
yes, yes. See, I'm doing more out hard. And just when it's going through. So we are coming to several lists of energies. And this data is we just want to put them on columns. We need to extract
So the Black Friday is coming. Let's get a new one.
Okay.
comp
No,
1,
it works. I don't know.
4, 5, 6.
I
So
don't,
the third component is
because I don't have
actually
enough.
6.
Mine, well, I gotta look here.
Third component of the vector is the 6th column in this record.
Okay.
Then we need to grab number 4 without to pull this energy. So
Okay.
the script does it. Now we,
I don't know what it means, but yeah.
yeah, I think it is done. So here we will K vector.
What's K over A?
This one is
Something of acceleration.
and here are the values of energies for the
But here,
They should go back to your thing.
If you look for the force length, first
Have.
this
So
should be minus nt. Okay. And then when it prints
it makes an
this
outcome
versus
one.
this,
Oh,
this one
you're
should
making
this and this.
Yeah, see, when you
call
do
it?
run fast, it should make an outcome one.
No. Makes an outcome. I don't have an
Just
outcome one.
pull this way, very similar to this one.
Okay.
Just try to pull file.
Here, this is, so I just ran my script. And
What's the outcome one?
That's in the header, in the file.
I have modified the script and edited it, so it is if we reduce our car only to those segments that contain our band energy, because there is so many
Yes.
garbage.
Yes.
So just and I was doing the grab key points,
Mm-hmm.
grab minus A15 key points, out car into out car 1. So it takes the keyword key points and adds the key points after.
Oh, I see.
So,
I
because
see.
otherwise it's 3,000 lines.
Okay. That works.
Everyone is happy? To some extent. And you see there is a development of these records that witness several self-consistency cycles, because we are doing DFT procedure. And the type of exchange correlation functional is stored in the podcast file. This one that we are using is optimized for so-called PB function, Purdue-Burke-Erzenhof. If you develop results for your project and your colleagues or referees will ask this which functional, you can answer PB. So if it doesn't achieve convergence until 60, cycle number 60, it will stop anyway, but hopefully it will converge before that. So we spent about a couple of minutes and it went through 16 steps. So it's maybe 8-10 minutes total to complete this job.
Quick question. Trying to copy that directory.
Minus R.
Aha! See, the record with
Minus
R
R.
did disappear. So there is a chance that
Minus R means
it has already completed.
So if you just have the type, like the directory name, it only copies that level. But you want to copy everything under it,
So
so you have to copy it recursively.
if we are looking to OSICAR, which is just
So that-
monitoring of the self-consistency
Not
steps,
where you're adding everything up.
you see that it
So I
shows
think
the
always think
final total energy
minus A
and it shows the magnetization.
is always sync.
When we were dealing with open shell models,
if you
magnetization was
calculate
always
it,
zero because they are not magnetic. And if this is bigger than zero, it means that there are some unpaired spins. So let's do the simple exercise of looking through our car file. I will scroll through until I see something interesting, and then I will go around and see that everyone comes to this point. So if you want to repeat it, just copy input files from this directory to your subdirectory, run wasp, and see the data. So if you are going through outcar file, we see this iteration, which is self-consistency cycle iteration, and there was about 20 of those. As soon as they are finished, we do see record for Fermi energy, and then list of orbitals. So you see the record k point 1, and there is only one k point. We intentionally requested only one, but there is additional record that we haven't seen before, spin component 1. And we are scrolling through, see number of orbital, energy of orbital, and occupation. Before it was 2 or 0, now it is 1. So we are scrolling and making an observation that for spin component 1, the orbital number 25 is occupied and number 26 is unoccupied. Right? 526. If we keep scrolling further, we see spin component 2. There's a list of orbitals, and you see something is different. Now for spin component 2, for spin down, the HOMO is 24 and LUMO is 25. So the number of highest occupied orbital depends on spin component. And the difference in these two numbers is the spin polarization parameter. So it means that there are one more electron with spin up than number of electrons with spin down. Good. So I'm going to circle around and see if you came to the stage, and then we'll go further with generating the density of states. By the way, there is an opportunity to plot orbitals, and they same as we did for those, and they will look differently for alpha and beta. So one needs to plot two sets of orbitals, alpha and beta. I think we did it in Gaussian. Alpha, A, MO, B, MO. And there is an opportunity to do the same with VASP software.
Oh, I'm good.
Good.
Yeah.
So you have these files.
Yeah.
Good. You got them.
But the values, it's like 25 and 26.
Yes.
I use the same file, and it's set 25, 26, and then one is 27, 28.
You didn't change the oxidation state.
Just the number of electron change, right?
Yes.
So,
So
49.
there are two
I did
heavy. Yes, but you need to remove this percent in front.
oh, okay.
This symbol means that do not look on this record.
Oh, hashtag means do not look.
Yeah.
Oh, okay. Thank you.
I forgot to change the oxidation state too.
Spin equals 3. You are a candidate for Nobel Prize if you find a more electron spins through.
Remember how to copy this? I like sort of remember. Yeah.
A little comment, as you will start doing your projects very soon. I know that we all are targeting big science, we have scientific curiosity, but practically, very important thing, name your directories appropriately.
What?
If you're running several configurations, like different oxidation states, do at the same level of directory tree, repeat the name of the compound and just add 2 plus 3 plus 4 plus. If you change spin configuration, just add singlet, triplet, because if you do it as you like, but develop your own system that you can navigate through. It's the easiest thing to get lost in your own directories. So see, it's like levels.
Yeah.
One level up.
But do we have to change the number of electrons too?
Whatever you want to change it to.
And then
Do you want it triplet?
You can
Do you want it to be,
For the +3.
then you
shows everything with
3 electrons away from the number of electrons, which
And then
I
you
believe is
tap and it
2.
automatically
Yeah, I was trying to do that.
Mine is the in-car for him is 55
Space.
now.
Here.
Obviously,
Everything
that already
is
changed
included.
the two originally, but he added 3 and 4.
Okay.
Okay.
But then I.
And then,
Then that would be a 3 minus.
You just look.
He added 3 electrons.
This one.
Or, that's what he did.
Okay.
So, there might have been,
And then you see same.
oh,
Okay.
yeah,
But
so
what
the
did you do
ha-
to change
ashtray
the
number of
oxidation state? That
electrons,
was the one.
I'm assuming that needs to be, like,
29.
yeah, because this might have been, you just copied it from another directory,
Oh, okay.
so,
Okay.
just explicitly wrote how many electrons I want to be to set. This model. All good?
For now, I think, yeah.
If you get it, it's gonna change the electron.
49 and remove hashtag and print.
It was like written like this.
Yeah.
So it's 14.
And then you can do it the second line.
So what do you need to find?
So if I just left the hashtag there and then
It reads if you have several
Okay.
versions of the same kind of
just
different
hope
numbers,
I
if you
see.
take the
That's fine.
Oh, it will?
yes, if you have those with hashtag will be skipped.
modify that file.
Okay.
And then how do I get out of this?
Escape or quit if you do not want to save, and right quit if you want to save.
Okay.
All good? Okay. So your home is 25 for up.
I'm running it again because I didn't join the spin actually, so I didn't
If we take open shell model and forget to put iSpin, it will be not trustable results qualitatively. It's not just getting half electron volt less or more precise. It will be wrong in principle. So if you predominantly know that it is a magnetic system, you can not skip iSpin equals 2. Good? How are you?
Yeah.
Good.
Oh, I'm at this step.
Uh-huh. So if you do not, you want your scientific career, you have some curiosity, but you're limited in time and you need to show productivity, and you do not target for like top journals. For the applied research on magnetic materials, it is sufficient just to scan through several configurations and report those density of states and just make radio observations. Because in this area it is not super demanding. If you want guarantee, like guaranteed minimum, you artificially set up high spin and low spin, compute total energy, subtract them from each other, and then tell, okay, it is the energy of magnetic ordering. So one can get to competitive level relatively quick. So everyone got to these numbers. So we are going to visualize them. The idea is that we need to extract these segments of data and then just process them in the same way as we did for closed shell density of states. Just a little reminder, I don't know if you care about it, but so when it assumes that at each energy there is a little peak, and has several peaks, then it converges into continuous line for density of states, right? So instead of delta function, one is using Gaussian overrides and with fixed width, where fixed width is determined by the temperature. If we do have two energies, E up and E down, we can do N up, energy up, and if you do have density of spin down, then we do the same, but just put here epsilon sub I comma down, or alpha and beta, and then we can draw it as pictures projected upwards and downwards. So we will be just doing the same in a practical sense. So what's the total number of orbitals here? 44. Okay. So we need pair of states, pair of files that will be named states up and states down, right? And we can just manually parse them out of the outcar. Just copy pasting or doing grep band energy, grep minus a so many band energy to take whatever is following this line. Or you can run this little code, extract energy, which will create this energy pop and energy pop down. So I'm telling more states up, and then it has a list of all orbitals, their energies and their occupations, and more states down. So given the list of orbitals, their energies and occupations. So just in case, here is the service file that contains first orbitals that we need, last orbitals that we need, and service number 1. So if you do not want so many orbitals, we can look of just a couple of orbitals near HOMO and WOMO. And here is the name of the command, to save your effort and not doing hard manual labor of putting numbers out of the big file. So I'm going to walk around and see if you have these two files, states up and states down.
Question, so for input overlap, you make the file?
Yes, you just,
Okay, you just make the
Mhm.
file itself, and then to make states up, you copy the energy out.
Mhm.
States down,
No,
same thing?
no, no.
Also, how do you do states down?
I have no idea. 49.
wait, you didn't run.
49 is
Run what I
both up and down, right?
Yeah.
Also extract energy.
Put that down.
Oh, yeah, I did.
Oh, yes,
Right.
yes.
I
yes,
did,
yes.
so I copied.
Or whatever
and
the
made states
keyword
down.
is.
Yeah,
Okay,
there's a
good.
49.
49.
And then I'll
And then you say I smear equals 2.
No, no, in
Oh, okay.
49
Oh, okay,
the
that's for down.
those,
Okay.
so it's asking for the electrons simulations.
I am writing my own script because I don't want to deal with any of that crap.
I didn't do with that one.
And then on 0.
Fine.
Well, they contain relevant information in it.
So I went into the input over.
I insert
So I copy energy up down into states.
colon right click.
I feel like you're becoming horrendous because you read a script to save in like 10 seconds, but it would take like 10 minutes to write. But I don't want to type in all those things every time.
Yeah.
Okay.
Okay, it's not that bad, but
Okay. And I missed the stuff you did after that, but
Then just see the last line.
oh,
there.
that's it.
Mhm.
Oh,
Ali?
Got my states up and down.
Good.
I made the, so this is the stuff I copied from yours. I made the states up and down.
Mhm.
The more overlap.
Mhm.
Overlap, we had
I,
148.
from the number of bands, number of orbitals is automatically established by VASP at each run,
Okay.
independently, and from run to run they can be different. There are some numerical criteria to select. So we need to look for the actual number of orbitals.
Okay.
I will be back if I need to tell something to you. Type something. What is NBA?
NBA.
Yes.
Basketball league, I think.
So grep NBA out card.
Association.
What are we expecting to get?
Number of bands.
Yes. If you do not want to go into the file and count orbitals line by line, we can number of bands and did you get this? Oh, you're going forward to the steps?
I got it for before they go on.
Okay.
What's the number of trains supposed to be in half of days or 40?
49. Yes.
But in one.
Typically, this error appears of
Fine.
inconsistency with 44 and actual edit.
Your call will be disconnected.
It's file name. Name is the file. Yeah, yes, file name.
Copy. State.
I mean, yes, yes, states. Yeah, that's the one. Thank you.
Oh,
Good. We have a figure.
I don't have this one yet, but that's my figure, that's story. I just had to times it by negative, flip it down,
How are you going to read?
just in my Python script, times -1 times the value, instead of
There's more relevant way.
in
In Gunplot,
Oh.
you can do U13 multiply,
like at this,
yes,
-1.
yeah. Well, you need to look for the manual for exact syntaxes.
But I can easily write it into my Python script, because I just go run.
Okay.
Avaya. Please enter your. The conference is now starting. You are the first person to arrive. You will now be placed into the conference.
But yeah, that's
Really, the only process important is so good. Like,
So,
I don't know.
I
if
probably
it's fun,
need
that's
to
all I
rush
know.
because you're ahead of me. Keep doing this.
No worries, no worries. I'll be here for a while.
Okay, thank you. Thank you.
So what?
Binary,
Dang it, now that's gonna be in my head.
rest, this.
No.
So, I'm just following this manual and repeating same steps as we do for plotting density of states for alpha and beta components, for up and down. So, typing this tilde binary request dot up, number of states 44, minimal energy, maximal energy. We can quickly look and see that the interesting activity is from -8 to -4, so probably it would be not wrong to explore it from -10 to 1. For the Fermi, if I didn't make arrangements, I probably should stop. Oh no, I shouldn't. I already grab Fermi car. Okay, now I have the value of Fermi energy and I'm doing this dress DOS. Number of states 44, minimal energy -10, maximum energy 1. Fermi energy, I'm copying what is extracted from the file. Alpha plus beta size, thermal width 0.1, magnitude 1, number of atoms something like 19.
Mm-hmm.
Makes sense. Number of electrons 49. Gap of titanium. Well, it doesn't change anything. Like it's 3. Dose up is written. Now I am enjoying to see that there are new files developed. Dose up norm, and then I'm repeating the same steps for the down. So the continuous line is saved in the DOS up norm. Number of states 44, minimal -10, maximal 1. Fermi, I'm scrolling a little bit back and repeating these numbers for Fermi and for alpha plus beta. Width of line 0.1 is a good 1. Number 19, electrons 49, 3. And now there are files for up and for files for down. And after that, we want to plot them together. So the code DOS up down, a set of commands for graphical plotting, and you see that it plots DOS up and DOS down, but each of them is plotted 2 times. One with color, another without color. So we plotting the occupied and unoccupied lines separately, just to indicate what is occupied. So WI means with impulse. WL means with line. So GNU plot. This one. Then we are looking into the directory and see that we have developed new file DOS up down.ps. If you want to convert PS to PDF. Now we may want to copy this file to local computer. individual directory, then the name of the compound. And just copying all files named with extension PDF into here. And now I need to find this file in the browser. Okay, so here is what we get and what you may get. So we are not interested in too many occupied orbitals and too many unoccupied because we do not play with more than ultraviolet light in our regular life unless we do X-ray detectors. And then you see that most of orbitals are symmetric. For alpha and beta orbitals, we have the same pattern here and there. And from our, if we would have more time, we should draw orbitals, plot orbitals for this system, which is not as difficult, but we better focus on absorption spectra, and then if someone wants to stay here, we can do orbitals, but it's secondary. But if we do them, we will identify that those occupied orbitals will reside on the oxygen from water in this hexa-aqua complex. And those 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 will be residing on the titanium. Those are 5 d orbitals on titanium. Typically, if it is, if you have 4+, then all titanium d orbitals are unoccupied, empty. Beta is empty. But here, this complex is mostly stable in the 3+ configuration, which means we have forgotten to remove one electron from the titanium d orbital. So it is here. And if we would prepare this complex in 4+ situation, then titanium d orbitals will be symmetric again. But as soon as we change occupation, it, like heavy, it pulls all orbitals down and symmetry is violated. So the pattern of orbitals is not as nice as it should be originally. What else? Symmetry inorganic experts present in class can suggest that in well, we can plot the orbital. You will see that octahedral. In octahedral coordination, the d orbitals exhibit two EG orbitals up, 3 T, 2G orbitals down. 1, 2, 3. So this a little higher peak corresponds to degenerate orbitals. So those are 3 T to G orbitals, and these are EG. And they both are available, both types of, and here is the octahedral splitting, which is about 2 eV here. So probably, well, it will be optically active. It should, the titanium 3+, what it is in experiment. If you just, titanium chloride in water should be something like, I don't know, purple.
I don't know.
But one can look online. I have a big suspicion that this compound will be colored. And this splitting, octahedral splitting, determines the color. If you change water to ammonia, this splitting will be different. Here are also this T 2G and EG, but they got corrupted because it is not absolute symmetry. There is influence from this electron, but those will be EG, and this 2 and this one will be from T to G. It is very pleasant way to spend your vacations or weekends. Just plot orbitals and find correspondence between your expectations, especially if you do it not for the class but for the research. Like if your research is dealing with metal-organic complexes, it is what you are expecting. It is what you are expecting to do. Please try to generate this plot, and we will continue in a second.
They could probably split it into Jan-Teller dispersion. Or would that not be included here?
Yeah.
It's D1. I don't know if D1 has Jan-Teller.
Why not?
I don't remember.
It's octahedral. It hates being high symmetry.
It hates being octahedral because that's not the lowest energy geometry.
Especially not since you have only one electron in there. So if you wanted to calculate your octahedral splitting, would you use the alpha side?
Well, that's the one that's popular. So that's the
No.
transition.
I don't, well, I don't know.
Okay. All right.
But I don't know which one is more. But the order between lowest of these three and highest of these three here and there is not as much different. And maybe, well, from the symmetry theory, there should be reasons to go away from this ideal octahedral.
Yes.
Yeah.
Jan-Teller?
Yeah.
That's what we just talked about.
If one goes to absolutely symmetric lattice, if one takes cubic lattice of some other mineral and replaces metal like lead selenide and replace lead to titanium, then probably the splitting will be much more ideal because these water molecules have degree of freedom to move around, and those hydrogens are also facing different directions and they may provide additional energy. Like mine. So we are quickly moving to research rather than academic learning because the semester is short. But if you would stay here if the course will be year long, here will be a right time for homework on plotting orbitals and repeating this calculation with different number of electrons and see which number of electrons provides smaller total energy. So find most stable compound, most stable oxidation state. Another exercise that would be naturally connected to it, that we just will probably skip for now, is a keyword n up down. Right now, we didn't set up this keyword. Okay, -1 means take whatever would be most favorable according to point of view of the software. But one can manually change this keyword n up down, and it means number of electrons up minus number of electrons down. So right now we have this difference equals 1, which corresponds to a doublet. For this system with odd number of electrons, we cannot go to triplet, but we can go to quadruplet. So if we set n up down equals how many? So 0 singlet, 1 doublet, 2 triplet, 3 quadruplet. So if you put 3, it will mean that 1 electron will be removed from this oxygen orbital and placed to one of these titanium orbitals. And then total difference of alpha and beta electrons will be 26 minus 23, right? So the energy of highest occupied up was 25, highest occupied down was 24, and if we will change them by 1, it will be 26 and 23, and their difference will be 3. So one can go from doublet to quadruplet just by this number. If we are starting with singlet, one can go to triplet by setting n up down equals 2. Make sense? Most likely we will have no time to have fun with these keywords, but some of you may need to play it in your research projects. So if your material is potentially magnetic, or it is metal cluster that has unknown number of oxidation state and unknown number of magnetic polarization, one may scroll through different values and find which one minimizes total energy. It would be a very natural direction of research for any metal-organic complex or metal particle. Spectra.
I don't like how this is sounding. It's quite a lot of writing. I don't like this. This is getting. Oh, a lot of it's just.
So same as for density of states, and everyone got the picture is density of states, right? No? Give me secret science if you didn't. Okay, I'll quickly go around, but I'll bring something to the screen so that you can go with spectrum.
Go to your command line. Make a new directory and copy your output outcoding. Oh, you got kicked off. So are you in the directory where you had the spin polarized calculation? Okay, can you copy that? Can you make a new directory? Copy your out card into that new directory. Go to that directory and type in capital, everything's capital, D-O-O.
Okay, wait.
So here is the command that you just need to type for alpha projection, and then same one for beta projection.
Then something. Okay. Then go into something. So CD.
Okay, where is your little manual?
Okay, now just type in capital dots. Try and tab. Okay, push enter. Oh. Okay, you can remove that directory. I was seeing if the script I wrote works for you, but apparently it doesn't. I don't know why though, and I don't care.
You don't wanna debug it? Can't remove that directory. How do you remove a directory?
Recursively. Mine, sorry. That's also if you want to copy a directory.
Instead of RM minus I.
RM.
But remove is what I use to like delete a file. Like remove the
Oh, so RM space minus R, the directory. That's weird.
What's the minus? You're recursively reading? So anything like inside of it you're removing as well?
Yeah. So like, if you think about the family tree again,
Yeah.
if you like disown your brother's family, you disown him, his kids, their kids, everything. So you never want to go into the main directory and say RM minus R star. Never, ever, ever,
Don't say that
ever,
now.
never do
You know,
that.
you said that.
What,
now.
what was that command again?
Yeah, that's I'm gonna be saying. I think Levi told me to do this at once. At some point.
Let's just say if that happens, there's gonna be some fire and brimstone, because Dimitri's gonna bring it down on someone.
Never do what?
Never,
Delete everything.
yeah, never delete everything, never.
No, just take this one.
I don't even know the command to delete everything.
That's why I'm not saying it. Like,
Yeah, because
No, that's
he
probably a
told
good
me, so
thing,
now
because
I'm
I
gonna be
probably
sitting there.
accidentally do it.
I think he told me this is the command to do.
no,
Wait, delete our own file or delete?
no, delete everything.
How? Oh, his stuff.
Everything
Oh,
in his directory.
but we can delete our own stuff, right?
Yeah, yeah, but that's your stuff.
Okay.
He doesn't care about that, he really kind of.
So I say I have
So you're getting
I have
up to work.
my folder here and folders down here, and I want to put all these ones into another folder here.
You just.
You mean
copy
halfway down on the first page?
Recursive.
Folded?
Yeah.
Yeah, no,
So I think
I'm
we
working on
directory
that.
move everything.
Let me know if you have
But
some.
why would you want to move everything into a new directory?
So I have my class, and then I have all this other stuff that we've been practicing. So
Where's that?
So I got stuck all the way back here.
So
So I did all that, but I got an error.
You didn't do all of these calculations in your.
no, I did.
Oh. What are we waiting
So all these folders that we've been kind of using for practice. These are like the
for? It's still in. Oh, so you
Yeah,
want
this
to
is
you
all-
want to clean this directory?
yeah. So if I wanted to put all these in different
Yeah, you just make it new one.
There isn't
in the are recursive,
That's weird.
or just in these ones, right?
I don't know. Maybe you don't have to do test. You might not actually have to do it. No, you don't have to do it. Moving to directories apparently.
No, well, I got an error, but it's not
If
copying.
you have a
There's
problem,
nothing- There's nothing.
just try minus R.
Okay.
Oh, if I did that. Because I think what it's doing is it's trying to grab these lines. Unless we're supposed to indicate the number of lines.
Now, don't get me sick.
I'm not sick.
Perfectly healthy as always.
Your voice does not sound that way.
No. Get to go.
Like a burrito from Taco Bell. good too.
Yeah. Forgot about that.
Yeah,
I talk about a long time.
I haven't either.
Okay. And then for this button.
Oh, it was like
I
the big
just
thing.
Oh, okay. So you
And I
just
don't
type in
understand
what you
why
want there,
it
and
Yes.
then it'll.
Ice cream.
How are we doing with spectra? Anyone progresses
Oh,
forward?
we're trying to do
This
this.
grep is not working for me. Not
Grep?
me. Yeah.
Double space.
Okay, I will go to the grep.
Oh,
That's what I
okay.
Oh, you already helped?
Yep.
Okay.
think so.
So, home binary spin os dipole spin up, and then the same go down. So as soon as you do have energy pop files and input overlap, they will run. So it is a demonstration of healthy development. Now, there is two sets of file: oscillator strengths, which will be oscillator strengths for alpha electron, for up, and oscillator strengths down, for beta electron, for down. If you look through them, more oscillator strengths. I'm just checking if there is a recording going on. So I'm looking for this oscillator strengths file, and you recognize the format as same as in your homework. So pairs of orbitals, oscillator strengths. The last three are three components of transition dipole, energy of transition, and occupation numbers. In comparison to what we had before we had always transition dipole from occupied to unoccupied. We had always 2 here and 0 here. Because if we perturb ground state of the system with light, it can go only from occupied to unoccupied. But if the system is in highly non-equilibrium, then it can go between any pairs of orbitals. Therefore, this format saves any pair. Like if you need photoluminescence from, then you can get your LUMO occupied, and it can give transition to HOMO, or it can go to second order absorption from LUMO higher up. Therefore, this additional information is stored. But if we just need linear absorption, we need to parse only those records that will go from occupied to unoccupied. So it is what was this grep command. And you notice that here numbers are 1 and 0 instead of 2 and 0. So we are looking that there are almost no transitions of the type that we are looking for. Most of them are from 0 to 0, from 1 to 1, inside band. But here I see an example from occupied to unoccupied. I'm copying it from 1 to 0 and do grep this pattern oscillator strength into service file that I need just for a short time. So this file will be much smaller, and if I'm looking more was up, then you see that all transitions are from occupied to unoccupied. And if you look for the length of the file, it will be like 4 times shorter, approximately. So it is what we need for linear absorption. Now we need to do the same thing for the spin down component. So we parse lines that do have transition from occupied to unoccupied for the down for the second component of oscillator strength, and bring it to a new file. just for curiosity, we see that files do not look of a big coincidence. So the transition energies are a little different coming up, and the values of transition dipole are a little different because this additional electron in the conduction band among the orbitals that are typically unoccupied spoils the pattern of absorption. Okay, now there is a shortcut. Like if we are tired and want to go home and go to preparation of our things, and then we do not care which electron is getting excited, spin up or spin down. So we can just fuse these two files together and process it as we did regularly. So it will be like necessary minimum for all of us. We will do it, and then those of us who are in a rush can leave. And those of us who are enthusiastic to do a little more, we can separately plot spectra built out of the alpha and beta component and see which of the components contribute more to the absorption spectrum. Experimentally, it is not as easy. It's probably need to placing the sample in the magnetic field to separate this alpha and beta component. But here we can do things that are not easy for experiment. So, fusing together these two files. So we have os down, os up. We can do concatenate, os up, bigger. Before we do it, I want to remove or move oscillator strengths into os strings up, so that now we do not have file oscillator strengths. No such file in the directory. So we will use this service file, this standard file name later for building the spectrum. So we do cut os up into oscillator strengths. Cut os down into oscillator strengths. WC oscillator strengths. To know how many files, how many transitions. So from this point, we can deal with it as we did before, as we did for spin non-polarized, for singlets. Just take this file and process it by converting set of elementary transitions into continuous line, right? Let's see that we can do it, and next step could be either go home or try doing separate partial contributions from alpha and beta. So we know how many orbitals, and now we do just standard spin spectrum improved version 3. Number of transitions. I'm just copy pasting this 955. Setting up the range I want to look at. Number of HOMO. I don't know.
So is that just arbitrary then, that number?
In the previous versions of the codes, it was looking from all orbitals below a given number to all above this number, and in the latest version, if it was not lost, at least I was manually changing it, if it was not corrupt because of everyone has access. It takes transitions from orbitals that have tag occupied to those that have tag unoccupied, independent of what HOMO and LUMO are.
So it doesn't matter.
It shouldn't matter. So what do we have? We have file spectrum. Just in case we will do partial contributions, we can make copy of this spectrum into spectrum complete. there is a chance to plot all three: contribution from alpha, contribution from beta, and contribution from both of them. But if you do not care about it, we do just standard GNU plot. Oh, wait. If you hate GNU plot, you just take this file and plot columns. First column wavelengths, first and second and fourth are transition energies, and the third one is intensity of the spectrum. But if you like GNU plot, then you type GNU plot tilde binary GNU prog SPE if you are fine with electron volts. And if you are not fine with electron volts, you type SPE nanometers. And PS2PDF rate spectrum PS and spectrum nanometer PS. So LS minus LT. So here is the list of new files, and I can go and download all files with extension PDF to the local computer, and then look in them. Open. So, even if we do not resolve it by spin components, we see that there is a transition a little above 3 eV, which corresponds to titanium dioxide and structures of titanium dioxide. So it is natural from O to P to T 3D, titanium 3D orbitals as target, and source as oxygen 2P orbitals. So this would be also in our homeworks for titanium OH4, where the titanium was in 4+ configuration. Spectrum, and this is transition D to D. Maybe the intensity is a little off, but in principle, in such configuration, there should be this transition between these D orbitals. So this one will be alpha, and this tail will be both synergy of alpha and beta components. So by now you have minimum practical skills to go to research. If your schedule is tight, if you are rushing to prepare your tomorrow presentation, I do not object to going home. But I'm just curious myself to look how it will look for the partial contributions of alpha and beta components to this spectrum. So now I am removing oscillator strengths file, and I'm just copying the os up into os strengths. So I will look only for contribution from alpha electron up. Now inspecting the number of the transitions, 475, reasonable. And now I'm running the same code for converting discrete set of transitions into continuous spectrum. So this code is looking in the directory for a file named os strengths, no matter who created and what is contained. Now we feed in only alpha transitions into this os strengths. You see here the CP os up into oscillator strengths. Now we run this one and answer a couple of these silly questions. 475 transitions, looking for the whole range with 0.1 width, whatever. And now there is a file spectrum. We can call it to the more generic, from this generic name to spectrum up. Yeah, you can call it CP spectrum into spectrum underscore up. And later we will plot three spectra, up, down, and complete. So now we have three components. We have some of them, and we need the down component. Now I'm going to remove oscillator strengths and feed in the down component. CP oscillator strengths down into oscillator strengths. WC os strengths, checking how many lines are in this file. 480, so it's a little different. 5 transitions more. And I'm running the same generic code that converts discrete list of transitions and their oscillator strengths into continuous spectrum. So 480 lines in the window from 0.1 to 10, line width 0.1. And now I'm copying the spectrum into spectrum down. So we expected to have 3 files: spectrum up, spectrum down, and spectrum complete. With spectrum complete being just algebraic sum of these 2 files for their spectrum.
Oh.
Right? Now we are going to just apply GNU plot to this script. GNU plot with these arguments. So this set of commands will be executed and it will generate the file sp_spin. And then we ps pd convert spin, convert into PDF, look that we have this file, and download it to the local computer. So as we discussed, and I promised that I didn't know what will appear. We were doing this model for the first time here. There are 3 lines: alpha component, beta component, and all together. So alpha red, beta green, all together blue. So the strong peak is D2D transition in alpha component, because we already have 1 electron among the titanium 3D. And the beta component has 0 at the optical range. Then in the UV range we have contributions from both alpha and beta, and we do not see contributions from alpha because they are they're hidden by the 3rd line. but the overall summation of these lines comes together and to this blue one, and it has both contributions from infrared range and then UV range.
But how is your blue smaller than red?
Because it is 1/2 average. A plus B divided by 2. Whew. So we do not have time to plot orbitals. We should go and prepare. Well, from now on, next how many hours? Less than 24 hours. Our primary goal is to make presentations. And I would appreciate very much if you send your slides by midnight. I need a little time to process them together, arrange them in the printout so that each of us can look through them. And also, I will, before printing, I will look through, and if there are some strong mistakes, I will communicate and suggest changes. Any questions? What will be last educational thing? Very last. So, list of the directory tilde binary in car. Bigger font. So here there is an in-car partial charge spin. So if you want to plot orbitals for this model, you copy this template in-car into your directory, rename it as an in-car, and rerun VASP. And then you will get set of partial charge files that can be plotted. And each partial charge will have both alpha and beta components. There are some other stuff that we can go through while doing research. Like one can change functional, one can do different types of calculations, like one can do normal modes, analysis, and something else. But enough for today. Lab is finished. I look forward for any questions. I will stay tuned for emails or maybe even phone or Skype calls. But we are going off records, and please send PowerPoint slides before midnight to my email. Thank you.